All right, so I am in a meeting this afternoon, so I wanted to make a video explaining about greatest common factor, okay? So greatest common factor is a number and or a variable that a quantity has in common, hence the name, common, okay? So the examples that they give you are here. You got this polynomial 3x cubed plus 6x. They took out a 3. Well, a 3 does go into both 3 and 6. However, they also have a variable in common. So the right way to do it is 3x, okay? So for the numbers, I'm going to show you a trick, okay? You can tell I already have Desmos open, all right? So what I do is I'm going to use something called, it's a function that Desmos has called GCF, okay? It looks like this, GCF with an open parenthesis, okay? So what I'm going to do on number one is I'm going to find the GCF between these two terms, okay? So GCF and then open parenthesis. And then I'm just going to put in the coefficients. I'll put 6 in every time. I need to put a comma, so comma, and then the next number is 9, okay? So what number do they have in common? They have a 3. So I can take out a 3. Okay? Now, what Desmos will not help me do, it will not help me with the variables. So we have to use the calculator in our head, our brain. Okay? So we look at this. Do they have a variable in common? Yes, they do. They both have an x. This one has x squared. This one has x to the first. So the most I can take out of both of them would just be a single x, x to the first. So there you go. That's the GCF. We did it. Okay. If I look at number 2, okay, I already have my GCF already typed in. Okay. So I don't need to retype the whole thing. So I'm going to just type in 15, and then I need to put a comma, and I'll put 10. Okay, so 15 and 10 both have 5 in common because 5 can divide evenly into both of those. That's what that means. 5 can divide evenly into 15 as well as in 10. And think about it. 15 divided by 5 is 3. 10 divided by 5 is 2. That's how we got these numbers in here. Okay, now I'm going to look at this. This one has an x cubed. This one has an x squared. So they do have an x in common. But can I take out more than just a single power? Yes, I can. This one has 3, this has 2, so the most I can take out of both of them is I can take out a square. Okay? All right. I'm going to do, I think, one more. Okay? Then I want you guys to get started on this. Okay? So if I look at number 3, I already have my GCF function typed in Desmos, so I'm just going to delete the 15 and 10. So I'll type in these two numbers, 8 and -2. I'll just do 8 and 2. 8, comma 2. Okay. Usually when you're doing the GCF, you don't need to put the negatives in there. So 8 and 2 both have 2 in common because 2 can divide into 8 4 times and 2 can divide into itself 1 time. Okay. Now, are there variables in common? Yes, there are. This one has an x, but this one doesn't. However, this term also has a y, and this one has a y. So it can actually just take out a y. And then we're done. Okay? So, guys, I want you guys to give this a shot, okay? I'm going to do one more. I'm going to look at number 10 down here, okay? Because I realize there's 18 of these. Okay, that's fine. Okay? So I'm going to look at number 10. Okay? So I did 1, 2, and 3 for you. Now I want you to look at number 10. Okay, first things first, I'm going to use Desmos to help me find the GCF between the coefficients. So I'm going to type in 12, then comma, 9. Okay, so they both have 3 in common. And if you want to work backwards, 3 times 4 is 12, and 3 times 3 is 9. Okay, so now let's say, do they both have an x? Yes, they do. So I can take out at least one x. Do they both have a y? Yes, they do. I can take out a y. Now, let's see if I can take out more than just a single x. This one has 2, but this one only has a 1. Remember, if there's no number on the exponent, it's implied there's a 1. So the most x's I can take out of both of them is a single one, or a single x. So there you go. And this one, y to the first, this is y to the second. So the most I can take out of both these terms is just a y to the first. We're done. Okay? If you want to put little ones there, you can. You don't have to. Okay? All right. I'll be back this afternoon. I won't be gone the entire class, but I want you guys to give this a shot, okay?